This is a review for the test. I'm going to begin with chapter 5 questions. What's the total area under the normal curve? It's always 1. Let's go to the next question. Determine whether the following graph can represent a variable with a normal distribution. Yes, you can see it looks like bell-shaped. If you press on the plus sign, you will see a bigger image of the graph. It is a normal curve. You can see the middle, the mean is right in the middle, so it's about right here, it's about 16 or 17, and then they're asking you to estimate the standard deviation. Remember, you go 3 standard deviation above the mean and 3 standard deviation below the mean. So if you press on the plus, you will notice you should go to 30, and if the median, let's say it's about 18 to 30 is 12. That's a 3 standard deviation. Divide by 3, you get a standard deviation, which is 4. So you would say, yes, the graph fulfills the property of the normal distribution. The mean is approximately 18 and the standard deviation is about 4. What is the area between negative 2.47 and 0? To do this, we'll just go to second, variables. It's a normal CDF probability. Enter. We need the lower bound, which is negative 2.47. We need the upper bound, which is 0, and then the mean is 0 and the standard deviation is 1. How do you know if the mean is 0 and 1? If it is a Z, the mean is always 0 and standard deviation is 1. If you have a different calculator, guys, you're gonna see this normal CDF parentheses. So put negative 2.47 as a lower bound, comma, don't forget the comma, 0, comma, 0, comma, 1, and then press enter. Oh, what did I do here? Oh, I used a different, not the negative sign. So this is the negative sign now. Now it's gonna work. Next question. Find the area to the left of 0.41. So actually he wants a probability of Z less than 0.41. Because it is to the left, it's less. How do you do it on the calculator? So you go to second, distribute, normal CDF. And what's the lower bound? As you can see, it's infinity, but from the negative side. So you use negative a million. Upper is 0.41. And then 0.1, and then you go paste and get the answer. Probability of X greater than 43. Now we want the area to the right of 43. So you can do the same thing. Second and distribute. Okay, normal CDF. I have to go up. Oops. Let me clear this. You have to put a number in order to allow you to clear it. Okay, now I'm going to clear. So go second, distribute, normal CDF. We don't use normal PDF. Okay, greater than 43. So the lower is 43. The upper, the sky is the limit. The mean is what? You are given the mean 50 and the standard deviation is 7. So when you ask about probability of X, you will be given the mean and the standard deviation. And here you go, you get the answer right there. In a recent year, the total scores of a certain standardized test were normally distributed with a mean of 500 and a standard deviation of 10.3. Answers parts A to D. What's the probability randomly selected medical students who took the test had a total score of less than 488? Okay, less than 488, guys, you go to second, distribute, normal CDF. Every time you do have less than, you have to begin with a negative a million. So negative a million. Enter. Oops, I have to go up. Your upper will be 488. Your mean is given in the problem to be 500. And your standard deviation is 10.3. Press enter, you get the answer. B, what's the probability randomly selected medical students who took the test had the total score between 497 and 510? Between is easy. The first one is a lower bound and the second value is the upper bound. So the lower value is the lower bound 497. The upper value is 510. And my mean is 500. My standard deviation is 10.3. I leave them the same. Paste and you get the answer. Find the probability that a randomly selected medical students who took the test had a score was between 497 and 510. Find the probability that randomly selected medical students who took the test had a total score of more than 526. Okay. Second, distribute. No, more than 526 means your minimum value is 526 and you have to go more than that, which is 1,000,000. Mean is 500 and standard deviation is 10.3. There's the answer. D, identify any unusual events. An unusual events, guys, where the probability answer is less than 5%. You notice C is less than 5%, but I don't think the other two answers were less than 5%, so only C is unusual event. Okay, use the standard normal table or technology to find the z-score that corresponds to the following cumulative area of 0.9479. If you have the area to the left, guys, to find the z-score is very easy. Look how you do it. You go to second, distribute, it's inverse norm. You put the area, which is 0.9479, enter 0.1, and here's the z-score. Every time you have a question about the z-score, the mean is 0, standard deviation is 1. Okay. The per capita energy consumption level in kilowatt hours in a certain country for a recent year can be approximated by a normal distribution with the mean of 2,326 kilowatt hours and standard deviation of 580.4. What consumption level will represent the 6th percentile? 6th percentile means the area to the left of the value that we are looking for is 6%. So 6% means the area to the left is 6%. So you use inverse norm. Enter. Okay, the area is 0.06. And then enter. The mean. Don't put 0.1 now. He's asking you for the next value. We already know the mean. It's 2,326. And the standard deviation is 580.4. And then paste and enter. So the answer is 1,423.6. He says round to the nearest integer, so it will be 1,424. All right, next one. What consumption level will represent the 22nd percentile? So it's the same thing, but instead of 6%, you put 0.22, 22%. So you go to second, distribute, inverse norm. You just change the first one. Everything else remains the same. The answer is 1,878. What consumption level represents the third quartile? Third quartile means 75%. So you go to second, and then distribute one more time, inverse norm, and just change this to 0.75. If he says first quartile will be, you might see the question on the test, first quartile, just use 0.25. Second quartile is the median, 0.5, and that's it. That's the answer. Okay, next question. The graph of the waiting time in seconds of a red light is shown below on the left with its mean and standard deviation. Assume that a sample size of 100 is drawn from the population. Decide which of the graphs labeled A to C would most closely resemble the sample and distribution of the sample means. When we talk about the sample means, X bars, when we graph X bars, they have to be normal. So if you want to select an answer, guys, it has to be a normal curve. So it can't be this. This is the original one. This is the original population. It's not normal. It looks like it's skewed to the right. So my answer should be actually either this or that. The mean here is 12.4. The mean has to be the same as the mean of the original population. Since the original population has 12.4, 18.7, they have to be 18.7. But you notice they are all 18.7. The only difference, guys, is the standard deviation. The standard deviation of X bar is the original standard deviation, 12.4, divided by square root of the sample size, square root of 100. And what is square root of 100 here is 10. And 12.4 divided by 10 is 1.24. So which graph has a 1.24? It's this graph C. So you choose graph C. Most closely resemble the sample and distribution of sample mean by mean of X bar, which is 12.4. And a standard deviation, which is 1.24. And the shape is approximately a bell-shaped curve. Did we miss anything? Let's move to the next question. The height of fully grown trees of a specific species are normally distributed with a mean of 79.5 feet and a standard deviation of 7.5 feet. He's going to ask you about X bar again. Random sample of size 19 are drawn from the population. Use the central limit theorem to find the mean of X bar and the standard error of X bar. Standard error, guys, of X bar means standard error of the sampling distribution means original population standard deviation divided by square root of n. So mean of X bar will be 79.5 and the standard deviation of X bar will be 7.5 divided by square root of 19, which is the sample size. Is it 19? Yes. So you do the math, guys, and you put the answer there. If you do 7.19, 7.5 divided by square root of 19, what do you get? So it's about 1.7. Choose the correct graph of the sampling distribution. So let's see which graph will resemble the sampling distribution here. So let's see. Is it this graph? The mean is 79.5. Look, it can't be this one because the mean is 0 here. So it's either this one. Let me see what this graph here, 79.5. Okay, but the standard deviation 7.5 divided by square root of 19 is about 2. So if you move from the mean to the end, you should move 3 standard deviation about 6. And look here, I have 79.5, it moves to 82.5, it's not a 6, so it can't be this one. Uh, 1.72. And if you go here, actually it is 1.7 times 3 will give you about 5, and 79.5, if I add a 5 to a 5.3 standard deviation, should take me to the end of this curve. So that would be the answer. This one is 79.5. If you add about 5 to it, should give you 84.5. But you can see before the tail there is a 94.5. So it can't be this one. All right. Next question. Find the probability and interpret the results. If convenient, use technology. The population mean annual salary for environmental compliance specialists is about 63,000. A random sample of 30 specialists is drawn from this population. What is the probability that the mean salary, it's about X bar. This question is not about X, it's about X bar. That mean salary of the sample is being less than 59,000. Okay. Same thing, normal CDF. Less than, you have to start with negative a million. Enter. Upper is going to be 59,000. Mean is given in the problem. Sorry, the question, yeah, less than 59,000. Mean is what? 63,000. What is the standard deviation? Remember, since this question is about x bar, the standard deviation is not only 6,000. It's 6,000 divided by the square root of the sample size. So it's going to be, guys, 6,000 divided by square root of 30. You don't put square root of 30, you're going to get a wrong answer. So enter, paste, and that would be the answer. Now the answer is 1.303984 e minus 4. E minus 4 means you have to move the decimal place 4 digits to the left. He's asking you to do it to 4 decimal places. So if you move it 4 digits, it will be 0.0001. So I just put, this is how you enter your answer. Okay. Now he's asking you to select the correct answer. It can't be 1%. This is less than 1%. To change this one, guys, to a percent, you have to multiply by 100. And actually, if you multiply by 100, it will be 0.01%. So it's going to be either this or that. Is this an unusual event? Yes, it is an unusual event. So this is an extremely unusual event. You choose this one as the answer. All right. So this is the review for chapter 5. I'm going to do it in 3 different videos. So I'll stop this video and then do another one for chapter 6 and then another one for chapter 7.